Hi, everyone. Just wanted to take a minute to talk about how to graph linear equations using slope-intercept form. As a quick reminder, slope-intercept form is of the form y equals mx plus b, where, as a quick reminder, your m is your slope. So your change in y over your change in x, or your rise over your run. And then your b, that is your y-intercept. So it intersects the y-axis at the point 0, b. It should help if I would actually finish writing intercept. All right, so now let's go over how we actually graph this. So the first thing we need to do in terms of this is we need to get a couple of points. The easiest point to start off with is to start off with your y-intercept here. So you know it is going to be 5. So when the x value is 0, y is 5. So there's your first point. That is what the y-intercept represents. When your x is 0, y is 5. And again, you can just get that from looking at the plus 5 or whatever's at the end here, the plus b. And then just remember the point that it actually represents is going to be 0, b, right? So in this case, it's 0, 5. All right, and now we are going to do the slope. So how we're going to do that is we're going to look at the coefficient of the x value of the x term here, and we have 1/6. So what that means is it is up 1, right? Because rise over run, the change in y. So we have a change of y of 1. So let me put that in different color. We have the change of y of 1. And then we have a change in x, the run, of 6. So over, 1, 2, 3, 4, 5, 6. There we go. All right, so there we're going to have our next point. Let me go back to purple. There we go. And there's my next point right here. We went up 1 to the right 6. Again, the way you probably heard me talking, I was saying the change in y is 1 and the change in x is 6. Because it's positive, they are both we're going up and to the right. Alternatively, we could also have a change of down 1, and then we would go to the left 6. So either is acceptable. We just have to make sure, because again, the negative represents down, positive up. And if we have it positive, that would essentially mean that they're both negative, right? So if we went down 1, we would have to go to the left 6. So that would also work. We could also have a change in y down 1, and then have a change in x of left 6. All right, over here. Oops. Okay. And then we have our line. And you're going to try and make it as straight as possible. All right. Obviously, if I was using the Rio graphing tool here, I would have had a much nicer line. But ultimately, I wanted to make sure we were clear on what we were doing with the up 1 to the right 6 or the down 1 to the left 6. Again, either is acceptable. In fact, sometimes it makes more sense to go up and to the right, and sometimes it makes more sense to go down and to the left, depending on kind of your starting point and things like that. So let's look at another problem. Let me just clear that one out. Start another problem, new problem. It's very similar. We're going to do a different one. Okay. So let's look at this problem. Let's look at this problem. So how do we do this? Again, still in slope-intercept form. So we, again, can still start with our y-intercept, which, again, we have here. When x is 0, y is -3. So we have the point 0, -3. And we need to be careful. We do need to include that negative. So make sure you don't lose that. All right. Now, we have minus x as my slope, as my x term here. So my slope in this case is actually -1. Even though it doesn't directly show it, we have the coefficient of the -1. That's what the negative is representing. So we have our slope of -1. And again, if we want, we can rewrite this so that it is a fraction, which might help us, of -1 over 1, right? So now because it's negative, we know that we're going to be, going down. So when we are looking at this, we can go down 1 and then go to the right 1, or we can go up 1 and to the left 1, depending on where you put the negative. You can put the negative with the numerator or the negative with the denominator. So if we put it with the numerator the way I wrote it, we would go down 1 for our change in y, and then we would go to the right 1 for our change in x. All right? Let me get that point right there. All right, alternatively, we could have instead put the negative with the denominator, still the same. We could have gone up 1, had a change in y of +1, and then a change in x of -1. All right? So ultimately, you'll see they're all in a line here. Now, I'm doing 3 points, but to graph a line, you only need 2, because between any 2 points is just one line, which is something you're going to learn about more in geometry. But anyway, between any 2 points, it's one line, so you only really need 2 points. But I just wanted to illustrate what it will look like. Okay. Whoa. Oh, we're just going to end that there. If I move my hand. Okay. So then our line would look like that. Okay. And if you were using a tool such as Delta Math, what you would do is you would start down here at -3. And as we just said, we went down 1 to the right 1, and bam, we would get something like that. See, they're only doing 1. We'll just look at that to confirm. Okay. All right. I hope this is helpful. Have a great day.